Have you ever been amazed by the strength and sleek beauty of titanium? This extraordinary metal is used in everything from aircraft construction to medical implants and even high-end watches. But how exactly is titanium produced, and what makes it so unique? Let's explore the incredible journey that transforms raw titanium into one of the most versatile materials on Earth. Welcome to All About Simple Things, where we uncover the remarkable stories behind the everyday materials that shape our world. Titanium doesn't come out of the ground ready to use. It's extracted from the earth in the form of ore. Most titanium is found in two main minerals, ilmenite and rutile. These minerals are typically obtained through open-pit mining, with countries like Australia, South Africa, and Canada among the top producers. Heavy machinery removes the ore, which is then crushed and washed to separate titanium-rich minerals from unwanted materials. Although titanium is the ninth most abundant element in Earth's crust, it is rarely found in pure form. This is because strong bonds with oxygen and other elements, forming stable compounds. Separating titanium from these compounds is challenging and requires a complex, multi-step process. After mining, the ore must be refined to obtain pure titanium metal. The most common method is the Kroll process, developed in the 1940s by William J. Kroll. The first stage involves converting the ore into titanium tetrachloride, a volatile and highly reactive liquid. The process begins by mixing titanium ore with chlorine gas and a carbon source such as coke. This mixture is heated to approximately 1000 degrees Celsius inside a reactor. At high temperatures, chlorine reacts with titanium in the ore, forming titanium tetrachloride, while impurities like iron remain as solid residues. The titanium tetrachloride is then purified through distillation to remove any remaining impurities, leaving behind a pure liquid. The next step, reducing the titanium tetrachloride into metallic titanium. The purified titanium tetrachloride reacts with magnesium or sodium in a vacuum or inert atmosphere. This reaction produces titanium sponge, a porous, rough form of titanium, along with byproducts such as magnesium chloride or sodium chloride. However, titanium sponge doesn't yet resemble the shiny metal we recognize. To make it usable, it must be melted and refined. This is typically done using vacuum arc remelting VAR or electron beam melting EBM. Melting. During this stage, the sponge, often combined with alloying elements like aluminum or vanadium, is melted in a vacuum furnace to eliminate impurities and ensure uniform composition. Casting. The molten titanium is cast into large blocks known as ingots, which are large blocks of metal. These ingots serve as the raw material for further processing. Forming. They are forged, rolled, or extruded into forms such as sheets, rods, and tubes, depending on their final application. This shaping process requires reheating and specialized industrial equipment. One of titanium's greatest advantages is its ability to form strong, lightweight alloys. While pure titanium already offers impressive performance, combining it with elements like aluminum, vanadium, or molybdenum enhances specific properties. For example, titanium aluminum vanadium alloys are widely used in aerospace and automotive industries because they provide excellent strength, corrosion resistance, and reduced weight. The alloying process happens during the melting stage. Small amounts of elements like aluminum, vanadium, or molybdenum are added to the molten titanium, creating a material with tailored properties. This makes titanium incredibly versatile, suitable for everything from jet engines to prosthetic limbs. After the titanium is formed into basic shapes, it undergoes machining and finishing to meet the precise specifications of its intended use. Titanium is notoriously tough to machine due to its hardness and resistance to heat. Special tools and techniques are required to cut, drill, or shape it without damaging the material once machined. Titanium products may undergo additional treatments such as polishing or coating. For example, titanium used in medical implants is often polished to a mirror-like finish and treated to enhance its biocompatibility. In contrast, titanium parts for aerospace applications might receive heat treatments to improve their strength and durability. While titanium is a remarkable material, its production isn't without environmental impact. Mining and processing titanium or requires significant energy and resources, and the Kroll process generates waste products that must be carefully managed. However, titanium's long lifespan and recyclability help offset these environmental costs. Many titanium products, such as airplane parts and medical implants, can be recycled and reused, reducing the need for new raw materials. In recent years, researchers have been exploring more sustainable methods for producing titanium. One promising alternative is the FFC Cambridge process, which uses electrolysis to extract titanium from it. This method has the potential to be more energy efficient and environmentally friendly, though it's not yet widely adopted. Now that we've explored how titanium is made, you might wonder why we go to all this trouble. The answer lies in its exceptional properties. Titanium is incredibly strong yet lightweight, resistant to corrosion, and able to withstand extreme temperatures. These qualities make it ideal for demanding applications, from building airplanes and rockets to creating durable medical implants and high-performance sports equipment. Moreover, titanium has a unique aesthetic appeal. Silvery gray color and ability to develop vibrant, colorful patinas make it a favorite in jewelry and luxury goods. Despite its high cost and complex production process, titanium's versatility and performance make it an irreplaceable material in many industries. The journey of titanium from mineral or deep within the earth to advanced technological applications reflects human ingenuity and scientific progress. It represents what can be achieved when innovation meets necessity. So the next time you see a titanium product, take a moment to appreciate the complex and fascinating process that brought it to life from deep within the earth to the cutting-edge technologies of tomorrow. Titanium truly is a metal for the ages. Thank you for watching All About Simple Things. Don't forget to like, subscribe, and join us for more stories that reveal the hidden history behind the simple things that shape our world.